Here we have another example of a radical equation. It's an equation that contains a radical expression. Our approach to solving this kind of equation is to first isolate the radical expression on one side of the equation. So in this case, what I'll do is I'll add that radical expression to both sides of the equation. Now the radical expression is isolated. Step 2, after isolating the radical expression, then is to raise both sides of the equation to the correct power to undo the root that we have here. The root we have here is the square root. So squaring both sides of the equation will undo that root. That's going to give us x squared here on the left side. And when you square a square root, that gives you the radicand. And now we can solve this resulting equation, which if we look at it, we should now recognize that what we have here is a quadratic equation. And let's put it into standard form first. I'll do that by subtracting 8x and subtracting 20 from both sides. And now I can use my methods for solving this quadratic equation. This is a relatively simple quadratic polynomial. Perhaps it's factorable, and it's not a bad idea when you simply have 1 for a coefficient of the squared term to do a quick look to see if the polynomial is factorable. Those are the easiest ones to factor. But if you struggle with factoring, or if the coefficient of the squared term is not 1, which makes factoring a little more difficult, then we can always use, as we've said, the quadratic formula to get the solution here. In this instance, this is a relatively easy polynomial to factor. I know it's going to be x times x in order to make x squared. To get minus 20, I have to have 1 plus and 1 minus in my binomials. And then how can I get 20 if I'm multiplying and get 8 when I'm taking a difference? Well, wouldn't that be with 10 and 2? So if I had plus 2 here and minus 10 there, that's going to give me minus 8x. So again, this was a relatively easy trinomial to factor. And when there's a coefficient of 1 in the squared term, you may want to give it a shot to see if it's factorable. They aren't always, and if it's not factorable, fall back onto the formula. So now I know my two solutions are x equals negative 2 or x equals 10. And once again, this is a radical equation. We squared both sides in order to free the radicand to produce an equation we could solve. We need to check those two solutions to make sure that neither of them are extraneous solutions. So if we go back to the original equation and put negative 2 in for x, so we have negative 2 minus the square root of 8 times negative 2 will be negative 16. So I have negative 2 minus the square root of 4 equals 0. Negative 2 minus 2 equals 0 is not true. So when I replaced x with negative 2, I found that I did not produce a solution. I did not produce a true statement. This left-hand expression is now has a value of negative 4, and that's not equal to 0. So this solution has to be thrown out. It's an extraneous solution. Let's see what happens if we put 10 in for x. We'll have 10 minus the square root of 8 times 10 plus 20 equals 0. 8 times 10 is 80. 10 minus 80 plus 20 is 100. That's 10 minus